Inequalities in one variable. We have four symbols that we use: greater than, less than, greater than or equal to, less than or equal to. The way to remember these is greater than has the larger part coming first. Less than has the smaller part coming first. The equal part has half of an equal sign in there. Okay? Now when we are graphing these on a number line, we have symbols that we use to represent these. Alright? When it comes to greater than or less than, we use an open circle. When it comes to greater than or equal to or less than or equal to, we use a dot. Alright? And to represent the numerical solution, we use arrows. Alright? So we're going to see that. Here we go. If I have 2x plus 3 is greater than or equal to 5. I am going to solve this like I would any other equation. I'm just going to bring down this inequality symbol like I would the equal sign. So first of all, I need to get rid of the 3. So 2x is greater than or equal to 2. Divide by 2. X is greater than or equal to 1. Now, this symbol tells me that I need a dot. Alright? So, make my number line. 0, 1, -1. I need a dot over my 1. Some people put it on the number line. I prefer to have it above the number line because then I can see my arrow more clear. Okay? So, x is greater than. That means alligator is the larger number. The larger number is x. That means my arrow shoots in the right direction. Alright? There is that. Next. If I have negative x minus 3 is greater than 6, I need to solve for x again. So I add 3. Now I have negative x is greater than 9. Now, I have a negative here. I have to get rid of it. If I divide by -1 on both sides, that will give me -9. That will give me x. However, when I multiply or divide by a negative, I have to stop and turn around. I have to go the other direction. So what that means is this symbol is going to flip. It's going to become less than. So on the number line, here's my -9. Here's -8. Remember, this is where 0 is over here to the right. So I have to have -8 there because it's closer to 0. And then -10 here. And this is an open dot at -9. Open circle. Okay, x is less than -9. That means my arrow shoots off left. Alright? Simple inequalities. Alright? So you'll be solving some of these. Next is compound inequalities. Okay, compound inequalities are either and or. And has endpoints and stuff in between. Whoops, got sloppy. All right, or has endpoints, but they shoot off in opposite directions, one or the other. Okay? So this is how your graphs will look. In and or situations. Okay? Now, if I have -3 is less than or equal to x plus 2, which is less than negative 1. Okay? I need to solve this inequality. So when I do this inequality, I have to subtract that 2 to get x by itself. But it's like an equation, except now I have 3 parts. What I do to one part, I have to do the others. Just like any equation, you have one side, do the other. So I subtract 2 there, I subtract 2 there, I subtract 2 there. Negative 3 minus 2 is negative 5. The symbols are the same, just add the numbers, keep the sign. Okay, less than or equal to x. Less than, again, signs are the same, add the numbers. Now put it on a number line. Negative 3, negative 5, dot over 5, open circle over negative 3, and there it is. It's in between. All numbers in between negative 5 and negative 3 are going to work. Okay? If I try to put negative 1 in here, is negative 1 less than negative 3? No. It is greater than or equal to negative 5, but it's not less than negative 3, so it fails. All right? Now, if I have x is greater than 6 or 2x plus 1 is less than negative 7. This one is already ready. All right, I don't have to do anything to it. This one I have to solve. I have to subtract my 1. So 2x is less than negative 8 divided by 2. X is less than negative 4. All right, so on a number line, here's negative 4, here's 6. I need open circles for both. Negative 4, x is less than it, means left. Okay, x is greater than 6, means right. There's your and your or situations. Everything needs to be graphed on a number line, all right? And endpoints in between, or endpoints opposite directions, all right? So that's the kind of thing you're looking at for inequalities. You have your compound inequalities where you have and or, and you have your simple inequalities where you just treat it like any other equation, solve it, and then put it on a number line.